As you know, Zurich is very strong in art and is also very strong in science. So I think a year ago, a group got together and thought, how could we combine these two fields and then profit from each other from different ways of thinking? So this is part 2 of the series. We started last year. This year we have, again, an amazing lineup of people who come here and expose themselves to other ideas and ways of thinking. So many thanks to all the speakers. Many thanks to all the people involved in this, the University of Zurich, especially also Schwarzes Café, Luma, who hosts us today in this beautiful space. That's about it. I wish you a very nice afternoon. It's going to be 3 talks separate by like 10 minutes, so don't run away after the first talk. Come back or take a coffee and then come back. Thank you for being here, and in bocca al lupo.
Thank you, Daniel Baumann. Thank you all for being here. My name is Gesa Schneider. I'm the director of Literaturhaus in Zurich, and I'm very happy to talk with Ravit Helled and with Matias Faldbakken. Let me quickly introduce them to you. Professor Ravit Helled is an astrophysicist. Her planet is Jupiter. She's specialized in Jupiter. I was very lucky to hear her talk in Zurich this winter at the Art Days. She is also very much involved in different projects, for example, the Juno project, where researchers really try to get beyond our planet and look at Jupiter and other exoplanets. She often speaks at scientific panels, but also at non-scientific panels. And she has been here at University of Zurich professor for the last 3 years. Before that, she was in Tel Aviv, but also in the US. Matias Faldbakken is a visual artist, but he is a writer as well. I know him as a writer. I first encountered him with his book, The Coca-Cola Company, which I read, I think, 13 years ago, and it has one of the most amazing opening scenes I've ever read. But he's also very much known as a visual artist. He has a piece right now at the Parcours in Basel. And what I'm very much interested in is also hearing what moves them, how they relate to the world, how they proceed in getting a better understanding of the world. These are all very philosophical, very big questions. And as I was preparing for the talk, or procrastinating would be more accurate, I was watching this Death, Love and Robots series on Netflix, and it's very much about getting different understanding of not only our world, but also in science fiction thinking about other universes. And so I think it's a possibility to get a higher stance, or to take a leap outside of this planet, and to see the world from a greater distance, and our everyday challenges from a greater distance. So we will hear first, we discussed this in the beginning, we will see first Matias' presentation, and then Ravit's presentation, and then we will have the chance to talk together. Okay.
Thank you. Yeah, I'm Matias Faldbakken, and I divide my time between visual arts and literature, and I'm just going to quickly walk you through a few examples of what I do. I would say if I would have to make some sort of thematic from my whole production as such, it's a little bit difficult, but I think I would say that it's about it's kind of about the antagonist, trying to understand the antagonist, trying to understand an antagonist position, trying to fuel myself with the enthusiasm, maybe an energy of the antagonist also. The antagonist produces conflict, and conflict is drama. So whenever there's an antagonist, something happens, and there's some kind of urgency, something is at stake. I've been approaching these kind of themes in a wide array of ways, both through language and also material, and in sort of gestural ways. So I'm going to show you a few examples. I've made many works with tiles, and they kind of reference areas in the city or in the urban space where the sort of governmental worry is high. This is where people are going to bring their kind of smutty behavior, and people, they know that stuff has to be cleaned up again. So it's like a promise of filth and a promise of cleaning, you know. Yeah, so variations of this. I've done for some years pieces that are based on other artists' originals, so historical original artists, that I kind of manipulate. I exhibit them like this one, upside down. It's always like a mixture between a homage and a sort of iconoclasm in a way. Then I use original artworks as my own raw material in a way. So I'm then grasping into art history and dealing with that. The last one was Gustav Vigeland, Norwegian sculptor. This is one of our famous national romantic painters called Hans Gude. I borrowed two of his paintings and hung them, tilted them in front of in a museum room where the view from the museum was actually the view that he painted 150 years ago. Before, yeah. I've made series of like serial objects, like lockers and archive cabinets and stuff like that, that I kind of squeeze together. I take like mass-produced objects and kind of make an original out of them by crunching them or crushing them, destroying them, and in that way, sort of conflating the creative and the destructive gesture. Yeah, here's another one, strapped to the wall. Yeah, these are big sculptures based on trench boxes, which are metal sheets that they put down in ditches where the workers are working in order to keep the ditches from collapsing. So I use a lot of materials from construction, transport, this kind of ephemeral, kind of invisible objects that are all around us, that can be monumental, but at the same time invisible. I often use objects as some kind of screens or some kind of carriers for imagery. So I glue images on objects so they become like a mix between a screen, a collage, or something that looks like browser windows or like a computer virus. Yeah. There's variations on that. Surfboard, blackboard, a big stone slab, sandstone. So a variety of different materials that I'm using. Yeah. This is a very recent piece. I started working as an artist by drawing, and this is how I got into it. I liked to make pictures with my hands. And I've been kind of getting drawing back into my practice. So this is actually a wall painting, like a wall drawing on tiles that I did in Basel now. So this is up from Monday, this one. And another piece. Yeah, here it is. It's on a basket court just close to the Basel Münster, the big church. And another piece, this one, a brick sculpture that is lacquered with bengalak, as we call it in Norway. It's like a shiny lacquer. And this is a sculpture that actually just answers to the, it's like a kind of like an unwelcoming bench. And it's then painted brick, and I wanted to make for a long time I wanted to make a sculpture with painted stone. And I heard that back in the day, the Basler Münster used to be painted. Latest with some oil-based paint, and in earlier times it was actually painted with ox blood. So I thought that this was a good opportunity to make a sculpture like that, sort of answering to the site. And then, on top of that, like 20 years ago, I started to write fiction. And I first, through like the first 7 years of the last century, this century, I gave out a trilogy called the Scandinavian Misanthropy Trilogy. And this is like a very dark comedy about contemporary life in Scandinavia, and all 3 books have different kind of themes, but they're all very hectic, aggressive, very incorrect in many ways. They're violent, they're pornographic, they are, there's not much hope anywhere to be found. But it was sort of my big take on. It was my first attempt of grasping what it means to be an artist. If an artist, traditionally you think that an artist is like has like a thoroughly good mission, and I try to flip that around and think, could you make like a bad or a mean or a nasty artwork that has no good intentions? Yeah, so that became 1,000 pages of that. And then I had a big break for 10 years, and I wrote a very calmer, a break as a writer for 10 years, and I wrote a much calmer book called The Hills that got me back into writing in a way. And this is a story, it's almost like a Kammerspiel, about a waiter and his life in a sort of grand European cafe. And he's a professional waiter, but he's also a neurotic. So he filters his surroundings through like a very kind of hectic way of thinking and dealing with stuff. And then, lastly, I'm just in the final stages of writing my 5th novel, which is something completely different. And which is why I think we ended up here together, Ravit, because Daniel Baumann, he asked me when he was visiting in Oslo if there was any theme I would think about for this talk, what kind of scientist I would like to talk about. And I said, well, this book is kind of about clay, so maybe a geologist or something, I said. And I think I got, no. So I think I got a little bit more than that. Because what Daniel didn't know was that this book is actually is almost like a folk tale about a family man in a place similar where I grew up. He walks into this workshop and he manages to give life to a lump of clay. So he managed to make a lump of clay alive. So it has this fairy tale aspect. It has a little bit of a science fiction aspect. In Norway, we have a funny fairy tale about a gingerbread man that comes to life and runs out of the house. Maybe you have this in the German-speaking world as well. But it also nods to very well-known myths like the Golem and the Frankenstein problematics and stuff like that. And this might be a thing that we can talk about, science run amok in a way. Yeah, thank you.
Thank you very much.
Okay, so I'm Ravit Helled. I'm a professor at the University of Zurich for Theoretical Astrophysics. I'm not part of the art world, unfortunately, because I learned that it's a really cool place to be in. So my day actually looks like getting to the office, look at the computer, go to meetings, look at the computer, come back home. But it's great. I love what I do. Okay, so I don't have these nice things I create to show you, because in the end it's numerical models and it's kind of boring. But I can tell you a little bit about what we are doing, or what are the topics we are thinking about. So planets, like the one we live on, it's a terrestrial planet. This is a small part of the topic. So we try to understand planets. So I'm a planetary scientist. I study planets. So there are a few big questions in the field. So there is a field of planetary science, and now it's even grew further to the field of extrasolar planets. So these are planets around other stars. We know that there are many planets around other stars. So we ask these questions I listed here. So how do planets form? We don't understand how these astrophysical objects actually form. What is the occurrence rate of planets? So now we start to answer this question. So that's, we know how many stars we have in the galaxy, but then we can ask how many planets are there. And now we know that, again, they are very, very common objects. What are the compositions of exoplanets? So these are planets around other stars. Are there habitable worlds, or is there life in the universe? What are the compositions of the planets in our own solar system, and is our solar system unique? Because we live in one planetary system, but actually it could be quite different from the other things out there. This is just a reminder. So this is our solar system. So this is our planetary neighborhood. We have 4 terrestrial planets and 4 outer planets, so the gas giant planets and the ice giants. Yeah. Okay, this is our home. You know this planet quite well, I hope. Okay. And this is just in terms of scale. So again, just to get a perspective, I think for me this is one thing that is important in my work, is that it's on a daily basis we know how little we are compared to the other planets. And of course, if you think about the scale of the universe, we are just on one very small planet around, part of a planetary system, which is part of a much bigger thing. So it's good not to take yourself too seriously. Okay. And in the field of studying planets, a huge difference or a huge surprise came in the mid-90s when the first planets around other stars have been discovered. Because until then, it was really a philosophical questions: are we alone? Are there other planets? And in the mid-90s, we actually detected the first planet around a solar-like star. So now we know that there are many of them, and we try to characterize them. Another milestone was in the 2000s, when it was a detection via transit, so we could say something about the size of the planet. And then when we have the mass and the size, we can say something about the density of the planet. And then we can start to characterize them and know what they are made of, and then think about life and habitability and so on. So this is a diagram. It's a bit outdated now, but what you can see is the semi-major axis. That's the distance between the planet and the star. So we are. This is in a log scale, but you can see where the Earth is. And this is the planetary mass. This is also in log scale in Earth masses. But the point is, you can see that as time progressed, we could detect more and more planets. The first planets that were detected, they were very massive planets, very close to the star. This is because of this observational bias that we had. But as time progresses, we managed to find smaller planets further out from the star. And we are, of course, still looking for Earth analogs. As I said, you can see this ends at 2014. Now this diagram is even fuller. And we try to go low in mass and far from the star, again, to look for planets that could have liquid water on their surface. And just the Swiss connection, so I told you that there was really this major change and shift in the field, and that was in the mid-90s, and that was because of the discovery of the first extrasolar planet around a solar-like star, and that was done in Geneva. So that's really why the field of exoplanets is really blossoming in this country. And again, the first one that was discovered, it was a very massive planet, so this is more massive than our Jupiter, orbiting extremely close to the star. This is something we don't have in our solar system, and that also taught us that actually what we had in mind about planet formation and how solar system look like, they can actually be completely different. So it really kind of shaped our thinking about planets in general, and this field is really growing, and people are working on that as I speak. Okay, so this is a similar diagram just to show you these are the different detection methods, but again, planets are extremely diverse objects. They come at different distances from their stars in different masses and sizes. It's really amazing. Again, just to keep in mind that what we see on our planet and even in our solar system is just a very tiny fraction of what is out there in the galaxy and in the universe, of course. And in my research, part of what I'm doing is I try to take the knowledge that we have in our solar system, because of course this is as I said, this is our planetary neighborhood, so we can send missions there and spacecraft and make measurements, but we have only 8 objects, so we know them very well, but there are only 8. And on the other hand, we have exoplanets, so by now we have more than 4,000 objects, but we don't know much about them because the measurements are kind of simple. So we have only very fundamental properties. And what I'm trying to do and we are trying to do is basically to combine these two perspectives of, a few objects, we know them very well, versus many, many objects, but we can only look at them in a statistical way. And again, use that to enhance our knowledge. This is another diagram that shows you some of these statistics. You have the planets from our solar system, which so we have the size of the Earth, Neptune size, and Jupiter, and you can see these are the planets that have been discovered, and actually it tells us that there are many planets in terms of the size between the Earth and Neptune. And again, this is the orbital period, so this is like the year or what we had before, the distance from the star. Again, you can see that it's very different from what we have in our planetary system. But we definitely see that that small planets are more common than large planets. So if you're thinking about habitability and life in the universe, actually it's good news, because there are more small planets than large planets. It's harder to form gas giant planets. So that's something we learned in the recent years. So when we collect all this information and this data, we try to understand planet formation. So I said one of the fundamental questions we try to answer is how do planets form? And we know it to zeroth order, I would say, but of course we want to understand it better. So in principle, the formation of planets is associated with the formation of the star. So basically when we form the star by a collapse of a molecular cloud, so this is a gravitational collapse, we have a formation of a disk, so it spins, and then there is a disk forming around the young star, and in these disks, planets form. Okay, so here there is supposed to be a movie, but it's not very scientific anyway, so it's not if it's not working, it's no big deal. Okay, it will just show you the simulation of a collapse of a cloud and then the formation of a disk around it. So the disk is basically mostly gas, so it's mostly hydrogen, helium. This is the composition of the star, of our sun. But actually, if you think about the composition of the Earth, it's very different from hydrogen and helium. And we try we investigate why it is like that and what determines the diversity of planets. And here you can see that this is, again, it's just a sketch of a disk around the young star, and you can see that there is a temperature gradient in the disk, so close to the star, so this is our sun, let's say the young sun, it's hotter, the temperatures are higher, and as you go further out, it's colder. So that means that besides hydrogen and helium, the other elements that can condense, different elements would condense in different radial distances, in different distances from the star. So this is why the terrestrial planets in our solar system, they're mostly made of silicates and metals, and this is because close to the star, these were the elements that could condense. And as you go further out, and here you can see that with the transition to the gray area, you could start to have condensation of water ice, and of course oxygen is a common element in the universe. And then you could form other type of planets. So this is basically the transition to form gas giant planets. So actually, this is a very nice and kind of consistent story. But what we learn from exoplanets is that this picture is probably wrong. And it's much more complex than that. So again, it's true to zeroth order, but not higher than that. Okay, so here we can see what I just explained about the temperature. So this is a bit more scientific because actually the disk becomes a bit more spread towards as you go out from the star. So here you can see we have this transition. So this transition is actually very important, as I said, and this is something we call ice line or the snow line. And this is the location from which further out, then we will have condensation of water ice. So again, there are many missing details in this theory that I told you, but in an intuitive point of view, even for the non-scientists here, it kind of makes sense. So we can explain in some way why the terrestrial planets are silicate and metal dominated, while we have something different in the outer part of the planet, of our solar system. Yeah. So going back to the big questions, so this is work in progress. So every day, every month, every year, we make a small progress in the field. So the questions are still there, and probably they're going to stay there for a while. And that's what drives our science. We try to answer these kind of questions. Thank you.
So thank you very much, both of you. So they're very, very different topics. So I guess we have to take, as I said before, a higher step. So what drives you? What is this thing behind that gets you in the search of knowledge, in the search of understanding either the world or something outside? And
I have sort of got a question. It's a little bit about, we're both in sort of the observation business, you could say. And I have a question about point of view.
Okay.
Because whenever, say if I start a novel, the first thing I decide is who's going to observe, and where I'm standing. And you guys with scientific observation are locked down more or less to Earth, or at least have Earth as the sort of launch pad. But last time I checked, one doesn't really know how big the universe is or where it ends. So in some sense, you don't even actually know where in the system or where the standpoint of the Earth is. So I was thinking a little bit in unscientific terms. I jotted down, what if our solar system is like the Darmstadt of the universe, like a periphery, an outskirt. And
it doesn't bother me, but okay.
Yeah.
It wouldn't bother me. If it would be true, it wouldn't bother me.
No, so I just wonder, how do you relate to that? That actually, the position from where you observe is actually not defined.
Yeah. So I'm a theorist. So I'm not thinking about observations, but we are aware of our limitations. So just like you said, we live on one planet, we are part of one planetary system, then we are only part of a galaxy. We can look at other galaxies, and at some point you cannot observe anymore. But there is so much that we can observe, and it's relatively close to us, which we cannot understand. So, and I think the fundamental questions in the field and in cosmology in general, they can be investigated even if you know that your point of view is biased. But I think that's a key point by understanding that you always look in one angle. And actually in the field of exoplanets, when people are looking for planets that are habitable, that we are looking for life outside the solar system, we always think about the Earth, and we always think about life as we know it. And this is just because we are very narrow-minded. We think in our terms. But I think when you do science, you have that in the back of your head, so you always try to relax that. You say, okay, I'm biased. I think in a simple way. I have to go out to think outside the box, try to change the perspective. So yeah, in a way, maybe it's the same. I don't know.
Yeah, and do you of course then see patterns from what you can observe, and if you do new discoveries, do you have sort of reliable patterns that you've kind of figured that this is the way it kind of multiplies outwards?
Yeah, so sure. You take the information you have and then you extrapolate, and you have to be careful when you do this, right? So when you conclude beyond what you have, we do that all the time. I think that's part of the game, but you have to be careful when you do that because you don't want to go too far from reality or the truth.
Yeah.
Yeah.
About the creation of how do you read images in science? How do you produce them? We have seen images there, but is there a system or a method?
Yeah, so there are different methods. So you can actually have images, like I'm sure everybody knows, like the images from the Hubble Space Telescope. So these are actual images, and then you can do that by measurements, and then what you get is numbers, and you know how to convert these numbers into images. But I actually had a question for you.
Yeah.
So for the creation of life, just out of clay. So do you have some kind of an explanation or description of the process in your book?
I thought I would get that from you now. How does life start? Because I
in your book.
No, this is like a hand worker. He's good with his hands. He's a carpenter. And he kind of accidentally stumbles into doing it. And there's some kind of, at least material explanation of what he sort of mixes together for this to kind of start moving around. But this is, of course, just fake stuff, all of it. That looks scientific to me, at least. I just take this as a premise, and then at this point when it happens, then this sort of kicks off the book, because what then do you then do with the life seeming object, But I sort of wanted to also pose a question back. Do you know?
The answer is no.
No. Okay.
No.
But what about the sort of raw material? What is needed? What kind of ingredients? Do you know a little bit about that, maybe?
A little bit, but really not so much. It's not exactly my field. But there are many people in the field of astrobiology and in biology, so for life in extreme environments. What is interesting is that the universe is mostly hydrogen and helium, and this is not what we need for life.
No.
So what we need is kind of carbon based.
Okay.
So life is carbon based. So we know that we need this heavier materials, so the heavier elements. According to studies, again, it's still being debated, but you need liquid water and you need some energy source. So many people think that you have to be somehow in the boundary between an ocean and land.
Okay.
You need to have, but in principle, the universe is also kind of full with organic material. So as long as you have organic material and again water and I just said oxygen is quite abundant in the universe. Again, statistically or from the scientific point of view, there should be lots of life. It depends how you define it and at what level of complexity, but statistically it should be there.
Right. Yeah. But the spark, that's to be figured out.
Yes.
Yeah. I also have another question because I thought a lot of this things you deal with are unseen things. So seems like you're working blindfolded most of the time. So I have a question about sort of imaginary space. I mean, a lot of space is actually just imagined done by us in some sense, even though you figure it's there, you haven't seen it, or a lot of the material at least. So how do you sort of weigh the facts against, the human mind's willingness to produce ideas and fictions, even, How do you in a way? Yeah, do you understand what I mean? How do you sort of tame the imagination with whatever you have from facts?
Well, I think I should bring back the question to you.
Yeah.
But I would say that I do not have imagination in my work. I have creativity, and I think this is what is similar. I try to, again, because we don't see certain things, and also in astrophysics, although we have facts, we can be off by orders of magnitude. Like, we just want to see that we can explain certain things, but it's not necessarily very accurate. I mean, sometimes we can be totally off. For example, in timescales, we can be, it's not about the uncertainty of a second or a year. We can talk about, millions, billions of years differences. So we stick to facts. So I mean, this is the way science is working. I mean, we stick to facts. There is nothing imaginary there. I mean, that's what you really have to. I mean, this is really part of your life. And actually, it's a little bit sad because, when you stick to facts all the time at work, you stick to facts all the time outside as well. So it's like you kill this kind of part of okay, let's go beyond what is kind of.
How do you know it's a fact? It's because it's mathematics.
Yeah, because it's
behind?
A measurement, because it obeys the rules of physics. I mean, I would also like to have this kind of extra dimension of happiness that would come to my life, but I cannot accept it because it's not scientific. No. So I want to, but yeah. So
for instance, like the tabloid science, I get the first image of the black hole that appeared.
Yeah, very cool. Yeah.
Yeah, right. What? Sorry.
Yeah, it was very cool.
Yeah, that was super cool.
Yeah.
But up until then, the whole idea of a black hole was what is it called?
Imaginary. No.
Yeah, a little bit imaginary, and this is what I mean.
Okay, so
So before you've seen it, it's actually something in your head.
Yeah, but you have not seen it. You just seen material around it, right? And then from that, you infer the existence of a black hole. So the existence of a black hole was also inferred from other measurements. For example, the velocities of stars. So it's using sometimes you use indirect measurements, but these are still facts. You see, so you're always stuck to facts. It's true that it's true that sometimes you don't have direct measurements, but when I study a planet and I try to say what is inside, I mean, it's also kind of imaginary, but it's kind of linked to facts. So but I think it's really the creativity in the sense that you have to you try to create something that does not exist, like a theory to explain how planets form. I mean, this is something that we cannot really measure. We can think what we need to observe in order to kind of support our theories, but it's kind of like your book. I mean, it just comes up, right? So, but how do you do that? Well, how do you feel about this imaginary versus reality?
Well, I mean, practically, I would say that my writing that's all imaginary. Writing is always abstract. Whereas in my visual arts, I make the stuff, I make the objects, I make the images. So that's like a very down-to-earth description of that. And this is what I go back and forth between, because I like the immaterial work of writing. It's totally immaterial. You need nothing to write other than, very simple tools. But with the arts, you always you don't need to produce. You can make immaterial art as well. But I have chosen to make object-based art, and this is because I learn something every time I deal with materials and I handle materials and manipulate materials. Yeah. But yeah, of course, the idea of what I'm going to do with the material is first conceived in my head.
We already need almost to close it up. I have a question, perhaps for both of you, thinking of your antagonism subject, and now that you explain that in science often you find out you can't see what is there, you can see only what is around. So it's sort of a very weird situation where you, like a blind spot, you talk about, well, you see the hole and not seeing the hole in this black hole thing. And there is this whole discussion about why first responsibility as an artist or as a scientist, and also about the divine, let's say, in the arts or in science. How is that something that concerns you in your research, or in both of your research? Or is that like saying no, all this question of God is not relevant at all as a scientist, or the mystery of research?
So I think the mystery of the world and the universe and the galaxy and our solar system, I mean, this is definitely, my driving force to some extent. I think as a scientist, what is important for me is to, kind of say that when we don't understand something, we don't necessarily need to go to some other solutions. We can just accept the fact that we don't understand things. And I can be the first one to stand here and say that there are many things I don't understand, but it doesn't mean that I just want kind of a fuzzy solution. It just, I can, I just have to accept that there are things I don't understand and I probably will never understand. And then the other thing is that when you do science, it's hard to connect to the public because it sounds like so far away. But I mean, for me, it's important to, again, just to think. I mean, we all live on a planet. We all see the sun. I mean, we are part of this system, if we want it or not. And at the same time, put things in perspective that, we are just a very, small part of something which is much larger, that the time we have on Earth is very, very short, very, very small compared to the age of the sun or the age of the universe. And if I can, talk to people about that, then I think that it leads to some change of perspective, which.
I totally agree on the don't understanding part. I don't understand stuff all the time, so I guess we have similar days in the studio and the lab in that sense.
Yes, just one last question.
My question goes to the imagination.
I will repeat it.
I grew up with a father who was a nuclear scientist, in between art and science, and he passed away last year. So I went more into science. So imagine, I understand what you're saying, but I don't agree with you. Because I'm very into Einstein. There's a quote from him. He said, imagination is more important than knowledge. For knowledge is limited, where imagination embraces the entire world, stimulating process, giving birth to the evolution. He's saying knowledge, you are saying fact. But I think, I went to this World Science Festival in New York lately. I actually sat there with the head who lead the team to take a picture of a first picture of a black hole. It was amazing experience. And he spoke with another Harvard scientist. I feel like there was so much imagination. So the scientist, the other scientist ended with the slides. He said, I have been trying to explain you about the black hole in an hour, and but he said, but I feel like at the end of the day, there's nothing I could say it. It's all this imagination. So there's this Indian mathematician. There's a movie called The Man Who Knows Infinity. In there's one chapter where he just writes a formula.
I'm really sorry. I have to.
No, I agree with you. I would call it creativity. You see, for me, it's the definition. I would just call it creativity, which is think beyond. I'm less comfortable with the word imagination, but I agree. I mean, of course, when you do science, you go much beyond, as we discuss, what is there. So, of course, you need this ability, or you need this other dimension. Okay, how it is exactly defined, that's a minor thing. Yeah.
Thank you very much, Matias. Thank you very much, Ravit, for this talk.
Well, thank you very much for this talk. Again, also from sides of the Zurich Art Weekend. It was great insight, I think, on both sides, the scientist side and the artist side.